Welcome back to the shed. My name is Mikael Sjöman and this is the Naval Tick Tinkerer. So I just want to show a little bit of progress today about a new project I'm building, and that is my 3D printed electric 25 horsepower-ish. It's actually a 20 kilowatt motor, a Flipski 85 165. So it's 85 times 165 long. And I just want to give an update where I'm at right now. So I started out with this, believe it or not. And I started looking at calculations, how much force could this take in this direction if pulling. And it turned out that, yeah, that should actually work. But I got a little bit scared and thought, maybe not. If I would put some 3D printed material on the outside of that one and adding that one straight on, I don't know if it would break. So I kind of hand laminated it with carbon fiber, multiple layers. And well, this is a learning journey as always, so of course I haven't done it right. I should have used these vacuum bags and peel ply and to kind of make them forge solid together. But I think I can actually continue working with this as a first prototype, and then we can move on. So where I'm at right now is that I have done a lot of iterations of this motor mount in OnShape. That's the one I know somewhat as a beginner. And as you can see, the process is basically, these are really thin, like 1 or 2 wall, just to see, how would this work? How would they lock together? So it's, how would they kind of stick along this rod? Or whatever you call it, the mast. I don't have a better name for it. I'm not a native English speaker. I'm from Sweden. I'm just trying and tinkering around. So I did these, and then I did these, and then I did these, and then I did even more. I tried to have screw-on versions, but I kind of ended up with a design where I have kind of coned in a little bit. And then I have these. So this is kind of how it looks when it's pushed in hard. So you kind of see the whole kind of bullet shape, and I have actually 3D printed threads in there, and God, they are strong. The amount of infill I have in this, you can see kind of, it's not a nice, I don't know if you can see it, but it's not a wonderful 3D print inside, but who cares? Yeah, I have like 6 or 7, actually most of this is solid through because you get double walls when you print them, and I'm using PETG. And there's a good reason for that, if you were thinking that I should be using something else, and I'll get to that. But yeah, so I've been doing lots of iterations. These are definitely not the only ones. I have way more. This takes time. I think I used at least 3-4 kilos of PTG. So thank God I found some good discounts. But okay, let's work from the same way I've been working with this. So I started with this one. I hand laminated this. I had some delamination, and yeah, it's not a great thing, but maybe it's more or less for looks and knowing. But I was hoping for a little bit extra rigidity around this one, but also that I would bake it in with epoxy and make sure that water doesn't get to the wood. Don't know if that's the best idea given the way I did it. You can kind of see it's not fully straight, so it definitely has delaminated a little bit and so forth. But at the end of the day, the calculations I did said that yes, this should be holding for the amount of force that is being pushed in one direction. Of course, there's more directions, but yeah, I'm tinkering it all and see how this works out. So what did I do next? After hand laminating, I started working with these. I did many iterations, drove my wife mad, and she said that I can't have more of these inside, so now they're out. Then I got the final one, which I have now, which works really nice. It looks beautiful, doesn't it? Kind of, it's gonna look great. So then I moved on to this one because I want this to be, removable. I don't really need it to be removable, but you can kind of see that I have holes here. And what I'm gonna do is something like this. I'm gonna put holes in the wood, push these down, the rods. And I'm gonna screw on and bolt this one on from under, so I can't change it if it breaks or if it gets destroyed, because often this part that is furthest down against the against the bottom of the lake or the sea, it actually gets beaten up quite a lot. So this is quite hefty. It weighs almost 300 grams, tons of plastics in it, and it's a snug fit, as you can see. Yeah, it's took some time to get it right, but thank God my good friend gave me a really nice caliper. It's one of those, was it Mitutoyo ones. So big thanks for that one. So now I'm done with this one, and I'll just have to create the holes from up here to align them perfectly, put some epoxy down, cut small pieces of this rod, bolt this one on, and then comes this little hole. So what is this? Well, this is actually quite heavy. I don't know if you can see, but it's 6, 7, 8 kilos. I don't know how heavy it is, but it's something like that. So the problem is that I have seen that others using these for e-foils, which is maybe most people don't use this huge one because this is this one has way too much power for an e-foil. But what they do is that they have a rod here coming out. So I built my own little rod system here. So those screws will go through this rod. Ooh. Be careful here. There we go. And I'm gonna cut this rod and make it come out here. And I'm going to put a little bit carbon fiber around it just for looks, but maybe it'll add some rigidity, and I will vacuum bag it this time. Or maybe you use pressure. I bought some tape to kind of force the carbon fiber to stick on the outside. Let's see how that works. Just still tinkering. So I'm going to put that one all the way out, somewhere here, maybe. Sounds good. And then I'm going to 3D print yet another one here. Probably from nylon, maybe carbon fiber nylon. It looks pretty. Carbon fiber nylon looks so neat. It's so beautiful. I love the material. So this PETG has this glassy look, but carbon fiber nylon, it's both a little bit more rigid, but yeah, it's also a heat resistant. So I might actually have to print this one in nylon too, not carbon fiber nylon, because I don't want different looks here. But if I print this one in normal nylon, that will basically be the same as this, I think. I hope. Mostly it looks the same, pretty similar. Otherwise I'll just have to reprint the whole thing again. The difficult part is that the printing, and it takes a lot of waiting, of course. I mean, one of these parts takes like 6-7 hours, even though I have a pretty decent enclosed heated 3D printer that costs like $1,000. But yeah, US, I'm talking here. So yeah, I'm gonna continue here from here now, carbon fiber in this one, so I get a rod out here. Then I'm gonna 3D print a mast holder against here, so that this one has support both from here, but also in this direction down. And while I'm working on that, I have already created the shape from here. So I started out with something like this, because this is the airfoil you get when you use on shape, and there's kind of plugins that helps you give the shape. But as you can see, I don't know if you can see, but let's see if we have one here. Yeah, here. You can kind of see that one is longer. And that is because having this one against water would create tons of resistance. So I wanted something a little bit too pointier, but not too pointy. And the reason for not having too pointy, which would be great, is that I want to kind of use this, which is carbon fiber weave, and I just want to put some out from outside of it. Don't know if that's going to last. I asked in a forum in carbon fiber and people who are using carbon fiber that they skin on the 3D printed parts, and they said that no, you shouldn't be worried. PETG has a melting temperature of 200 Celsius, but I mean it can start deforming at 75 Celsius. So yeah, I don't know. Let's try. Worst case, I'll have to reprint and do over and over again until I reach perfection. But what I do know is that nylon doesn't stick well to carbon fibers, and actually it's the epoxy that is the problem. It doesn't really bond too well. I guess there are special epoxies, but I got these two and I want to use them in my project. Okay, so then I have these cables and they have to run here through, and how I'm going to do that is here. You can kind of see this is for the plank and the carbon fiber plank, I don't know what to call it, and then I have made a hole here that I tried fitting around these so that I can actually pull them. So you can imagine that this one is going to be long here. And then after I put these on, I'm going to put carbon fiber around so that you get this carbon fiber look at least above the waterline. Maybe I'll add some here. Since I have it here, it would be nice to probably have it here too, but it kind of becomes weird because this kind of shape and putting carbon fiber, I mean, I could put one layer like that and then one layer like that, but I don't know. I don't think that's going to be great. So yeah. What's next? Yeah, you can kind of see it's 3D printing is sadly a lot of waste, but I take it to the recycler. I tried different versions here. You can see the ones with the kind of screwing on. That was a great idea until I realized that you can't just have the screw, you have to have screws in here from the side too to kind of lock it in place. And then I realized that these are just complicated and yeah, it's probably not going to help that much. But the final version with this one, I mean, these screws, you wouldn't think that if you 3D print threads into plastic that it would be great. It was freaking awesome. I did tests, and I've seen tests online too, and my god, they are strong. I don't need any inserts or anything like that. If you don't know what inserts is, it's this stuff. Let's see. So, I don't know if you can see them, but they kind of push these in the plastic and then you can draw screws through them. This is quite small ones, not for this project, just some extra I have. So I think that's the update for this time, and I think I'm going to continue like this. I am not going to edit a lot and keep doing it. I'm just going to keep posting some small updates of how this 25 horsepower electric engine is moving along, and yeah, share with the community. And thanks for all the help, all the comments in the forums, for you guys who has helped me. Really appreciate it. It's going to be really interesting to see it soon, at least in a few weeks. I should have this done. Then I have the motor mount, and I have the speed controller with a water pump also. So you can see I have one small hole here, and maybe I'll use, like most outboards, they kind of have a hole somehow that kind of, when they drive against water, the water gets pushed against that hole, and then the water goes up and cools the engine. And I'm going to need cooling, not for the engine, because this one is underwater, but what I need is the ESC, the speed controller. It can easily become like 100 amps running through that continuously. It's a 300 amp speed controller, so running at that battery I built there. It's battery pack, it's from the previous project. So yeah, we should have 84 volts at top times 100 to 200 amps, and that's fairly decent, I say. It's what's that, 16, probably peak. I can for a couple of second runs at 20 and get the full speed out of it. And I got this new propeller also yesterday, so fits like a glove. If you order, make sure that you count those, I don't know what to call them, kind of threads that goes in. And don't get this type of version. Try to get the one you can screw in and then put the nylon, what's it called? Nylock bolt here to kind of connect it. So I think this is turning along quite fine. So yeah, next steps, that one, and then keep working down there. Carbon fiber nylon there, and here normal black nylon. That's what I'm going to do. PETG, 75 degrees, 200. I don't really like it. I don't want this to start gluing together when it gets real hot. It could get real hot since there's so much current going through here. So even though it's going to be water cooled just by being inside water, which simplifies a lot, I think it would be nice to just have this one maybe with nylon, which has kind of double the heat resistance of PETG. Maybe not double, like over 120 Celsius, I think, before it starts deforming. But this one has a 75 degree Celsius deforming level in heat. So let's see. Thank you for this time. Hope you enjoy the video, and yeah, see you next time.